All right, welcome back to CS Skills Exchange. Great show for you today. I want to turn it over to our presenter today, Simon, and get us started.
Hi, everyone. For those of you that don't know me, Simon Mansfield, Solutions Architect here. What we're going to be talking about today is GraphQL. And for those of you, I'm not expecting any of you to know anything about GraphQL, so you have no idea what it is, then don't worry. I've assumed no knowledge here. But what we're going to be talking about is GraphQL because GitLab is going GraphQL first, and we have been GraphQL first for some time now. So let's just dive into what that means. So first and foremost, this is our agenda. So we're going to go through an example use case. I think you'll find use cases quite lighthearted and funny. We're going to talk about REST and how you might use a REST endpoint, so an API endpoint with our example use case. We're going to talk about why that is less than optimal or the problems that it has. And then we're going to bring in GraphQL. So we're going to talk about what is GraphQL and how does it solve these problems. And then finally, with that knowledge and our very light and fluffy example use case out of the way, we're going to deep dive into, I'm going to show you GitLab's GraphQL API running live in a production environment, and we're going to explore that and show you some of the power that GraphQL endpoint has. So really, for those of you that don't know, GraphQL is a way of querying data. So GraphQL stands for Graph Query Language. It's a way that you can write an API, and the reason why it's called Graph is because, as the symbol they use is that it's meant to represent a data graph. So you quite often these days, when you're requesting data from an API, lots of data is related. REST endpoints aren't great at kind of giving you that relationship. Quite often you'll have to kind of piece things together, as you'll see later, with IDs from different types of endpoints. And that's pretty much how the GitLab API works as it currently stands. So the REST endpoint, I should say. So let's talk about the use case, the example use case we're going to talk about here. We're going to consider a web page or a web application that's going to display a list of adorable pets that are available for adoption at a group of animal shelters as our example. So here's a load of cute pets. We're going to want the web page to be fast, as everybody does. We want it to be responsive. We're probably going to want it to be mobile first, and all of the other good things that people expect these days. We want it to be a good best practice example, which is going to cause some challenges. So first and foremost, managing data in modern applications is challenging. So quite often we have various different front-end clients. So it may be that we want to develop an iOS app for this particular example, but we also want it to be web-friendly. We may need to even have some customized other versions of the application, for I don't know, pet breeders or something, each with different data requirements. So there's, depending on where the application is being displayed, it comes with different data. So whether it's mobile or desktop, you're working with very different screen real estate, and you may have different subsets of data that need to be displayed on the home screen, just as a pure, simple example. The backend service that actually serves all the data to the clients is going to be potentially serving the data from multiple different places as well. So a lot of the data is going to be stored in a database, but that could be a Postgres database, but there's also Redis databases and Memcache and all the rest of it. So it may be that you're using a multitude of different data sources. And I won't even talk about like federated data sources, so where you're pulling data in from other applications, but there's those considerations as well. And finally, complex state and cache management for both the front end and the back end. So data changes, data constantly changes. How does the client and the server respond to those data changes, and how does it propagate them to the front end? So how do we solve this? So REST to the rescue, maybe. So using REST, the page. Let's just take a hypothetical example. Hopefully all of you can see that large enough. The page that we're developing might need to say, display a list of dogs that are available, whether they're suitable for rehoming with cats, and their current location, so which shelter they reside in. So quick, simple. You can imagine this is, you know, your homepage list of dogs that are available for rehoming, that are suitable with cats, and where they are. You know, that's fairly reasonable expectations. But to do this using a REST endpoint, you might have to do it like this. So you might have to get a list of dogs that are in all of the shelters. So using over here, you've got this sort of generic pause. So we're calling them pause here. This pause endpoint, and you're saying, hey, I want 3, and I want you to start at the beginning. So here's a list of pause. But the data we're getting back here is incomplete. We're just getting the name and the cover photo and whether they're reserved, because this endpoint maybe hasn't been designed with this particular screen in mind. It's been designed with another screen in mind. And so we get the poor IDs here. And so if we want to find out whether these dogs are suitable with cats, the next thing that we need to do is go and then get each pet that's been returned's individual details. So we need to query 1, 7, 9, or 27. And we get more information about this particular dog. So this particular dog, Queen Elizabeth, has some photos, has some cover photos, is not reserved, is not suitable with kids, is not suitable with cats, is suitable with dogs, etc. So best case scenario, we go and do this. So we make this request and get a list of dogs. And then we have to go and make another request for each dog in this list to go and get the details that we need so that we can find out whether they're suitable with cats. And then we still don't have all the information we need. So because we need to know where they are. And so all we've got as part of the details down here is the shelter ID being 3. And this is a very common, you know, sort of almost you're getting the database data here at this point. So it might be a link field. It might be actually in a linked table. But the long and short of it is this is a field that links this dog to a particular shelter, which is probably being held in another table somewhere in a database. And you're getting a sort of a glimpse into the underlying data structure here. But all you were getting is this number 3, and we need more than that. We need, you know, the name of the shelter and where it is, so that if we wanted to go and see this dog, we know where to go. So yet again, for every single shelter returned or shelter ID returned as part of each of these requests made for each dog, we now may need to make another request, potentially 1 or more requests, to go and get the details of the shelter. So for each shelter, we go ahead and get the details of that shelter. So this one, Puppy Love in the Isle of Dogs in London, tells us how many, what capacity they have and how many guests they have. Great. So with all this information, we can piece this together and we can display the screen now. But this solution requires multiple dependent network requests, which is going to result in far slower page load times. It's going to result in additional battery consumption on mobile devices or low power devices. And the logic's also really difficult to reuse on other pages that display different data. So you could argue that, okay, you know, this could have been designed for a different page. So one solution would be to create a dedicated API endpoint for this particular use case, for this particular UI screen that we're on now. So basically make one that returns pause, you know, with, you know, you call it pause with suitability for cats and shelter. And what it will do is it will return, you know, the same information you've got here, but with the additional suitable for cats and maybe the name and the location of the shelter included in this response. But this is a very specific API endpoint, and it's very specific to the UI solution that we're trying to solve. So it's incredibly inefficient and time consuming, because what you're going to end up with is numerous endpoints that all have similar functionality, and they're all going to return vast amounts of data, quite often much more than is required. And so it's not great, because every single time if someone in the front end wants to make a change or add a new update, they have to create a new API endpoint. And it's just you're involving back end and front end teams when you don't need to. So what other issues can we see here? So we've already sort of talked about the network fetching side of this, but there are other issues as well. So let's take this API endpoint for getting a single dog. So we've got an example data on the left-hand side and some issues on the right. So some of the biggest problems with REST is overfetching. So overfetching just is purely meaning that the client is getting much more data and much more information that's actually required to be used inside the application. So take an example of the screen that needs to display a list of dogs with only their names. In the REST API, this app would usually hit the pause endpoint and return a JSON array with an array of dog data. This response, however, contains far more information about the dogs that are returned, i.e. it returns their cover photo and their reservation status, information that quite frankly is useless in this particular use case, because it only needs to display the dog's name. So that's one example. The other one is underfetching. This is the worst one. So underfetching causes n+1 requests, the n+1 requests problem. So underfetching generally means that a specific endpoint doesn't have all the data that you need. So what that normally means is that the client will have to make an additional network request to fetch everything else that it needs and then kind of combine them. This can escalate into a situation where a client needs to first download a list of elements. So in the previous example, a list of dogs and their IDs, and then needs to make additional requests per element based on that ID to fetch the required data. So in the previous slide, so just to go back really quickly, we were going to have to make one request to get this, and then one request per each of these in this list. So that's an example of underfetching and the kind of problems that solves. And other questions to kind of ask here, what are the types of the return data set? So we're talking about data here. Like the client is REST doesn't give you like any hints. You've just got a URL to hit. So get API pause 27. So you're completely relying on documentation. So everything's being done by contract in terms of reading API documentation, ensuring that you're aware of all the edge cases. So you don't know what the structure of this REST endpoint is going to return until either you make that request or you look in the documentation and it very clearly details what the data set returned is going to be. It doesn't give you any hints as well about what the data types are even going to be. So what is poor ID? Is this a number or is this a string? It could be either. We have no idea. Unless it's documented in the API documentation, you're not going to know. Then it's also some really interesting questions like, hey, this example is great. So let's say you've queried the API and you've got an ID. You can see what the type of data set it's going to return is, and you program all the front end based on this. What if there is no cover photo? What if it's a brand new dog that's just been brought in and it doesn't have a photo yet? What's it going to return? Is it going to return null? Is it going to return an empty string? 0? False? You have no way of knowing unless, again, it's documented. And these are the real edge cases here. So what if there are no photos? So the prime example now is we've got this photos field here, which is an array of other photos. What if there are none? Do you get an empty array or do you just get null, false, etc.? What if they're uncertain about Queen Elizabeth's suitability with kids? I'm trying to say it correctly without slipping. So at the moment, we've got true and false down here. That's great. It's Boolean, 1 or 0, true or false. But if they don't know, how do they represent that? Is it going to be null? Is it going to be undefined? Is it going to be a string saying unknown? How do we know? All these kind of problems cause headaches for teams consuming these APIs. There's a lot of trial and error. There's a lot of reading API documents, and really you're relying on your ability to read documentation thoroughly and not missing any of the edge cases to make sure that your application is stable and doesn't error or crash. Also, another common pattern with REST APIs is to structure the endpoints according to the views that you have inside your app. So we've just talked about that in the previous slide. This is handy since it allows the client to get all the required information and for a particular view just by making one endpoint. But request, sorry. But the major drawback of this approach is that it doesn't allow for rapid iteration on the front end. With every change that is made to the front end, there is a high risk that there is more or less data required than before. So consequently, the backend needs to be updated or a new endpoint created or an existing one changed. But it may be that more than one UI front page is actually reliant on that endpoint. And so actually by removing a piece of data or adding a new piece of data, you might break functionality somewhere else in the application. This just kills productivity and slows everything down. So there's all the pitfalls of REST. So what is GraphQL and how does it help? So GraphQL to save the day. So GraphQL is actually a system designed a schema designed by Facebook. So it was originally, the concept was created by Facebook, who obviously have a very large social data graph. And so it's a problem that they know well. And they describe it as this. So GraphQL is a query language for your API and a server-side runtime for executing queries using a type system you define for your data. GraphQL isn't tied to any specific database or storage engine, as instead backed by your existing code and data. Okay, what does that mean? What it means is that really, when working with GraphQL, you really just have to follow 3 simple steps when you're either designing and working with GraphQL APIs. So you generally start by describing your data. This is all the server-side stuff. So this is the equivalent of writing the REST endpoints. And then you ask for, then as a client, you then just ask for what you want. And then number 3 is you benefit. You get these predictable results. So let's take a look at this as an example now. Sorry, all the nice, cute dogs have gone now at this point. So this is an example of a server-side implementation. So a GraphQL server uses a schema to describe the shape of your data graph. This schema defines a hierarchy of types. So here's a few types, dog and shelter, with fields that are populated from your backend data stores. Notice stores, plural. You can actually have different fields coming from different places. The schema also specifies exactly which queries and mutations are available for clients to execute against your data graph. So on the right-hand side here, you've got the queries and the mutation types, which define which endpoints are available for your clients. So here we can see an example schema that defines 2 object types, dog and shelter. A schema typically defines a collection of types and relationships between those types. So you can see in the example schema right here that every dog has a shelter, and every shelter has a list or an array of dogs. By defining these relationships in a unified schema, we enable the client developers to see exactly what data is available and request a specific subset of data with a single optimized query. Note that the schema is not responsible for defining where the data comes from or how it's stored. So the schema is literally just saying, I'm going to give the client this data in this format. It's not the schema itself is not responsible for defining where it comes from. That's generally done with something called a resolver in the back end system. I'm not going to go into the nuts and bolts of how that works, but there's further reading at the end of the slide. So if you want to learn how that works, that's great. Do have a look. A GraphQL schema is most powerful when it's designed for the needs of the clients that will execute operations against it. So although you can structure your types so that they match the structure of your backend data stores in your database, you don't have to. A single object types fields can even be populated with data from any number of different sources. So in short, design your schema based on how data is being used, not based on how it's being stored. So you can see here, we've got rid of this shelter ID. Shelter ID is an irrelevant field when you're talking about a dog. The only reason why you'd have shelter ID is to tie it to a particular shelter. We haven't included shelter ID because there's no need. We can literally just query the shelter straight on the dog. So we've got this relational, this graph link from dog to shelter here. So storing things like shelter ID as part of the dog type is an easy beginner's mistake to make with GraphQL, defining a type exactly how it mirrors the database. And yeah, as we just talked about. The next point I just want to make is that the types have fields, you've probably noticed. So we've got ID, name, cover photo, and they're typed. So all of a sudden, we've just gone from a REST API where you might have, this REST API returns a data in this structure, ID, name, cover photo, but it might not necessarily tell you what types they are, to all of a sudden, not just having a schema telling us exactly what will be returned and what additional queries we can make on it, but also what types they all are. So for example, the reserved field is a Boolean. So this means that, the schema not only describes the shape of the data that can be requested, but the types of data that are going to be returned predictably. This is going to make client development so much easier because rather than having to read an API, it sort of self-documents itself. You'll see it when we get to the demo in GraphQL that you can get access to all of this, and it'll tell you the types of data that are being returned. And it will tell you that ahead of time before you even make the request, because it's documented. And that means that you can tie it into typed languages like TypeScript, which means that the types of the data you're working with from requests can actually flow into your application. And you can make sure that you're handling all the different types of data that are being returned correctly. And there's no edge cases that you've forgotten. So that was from the server side. Let's talk about it now from the client side. Client side, great thing is it looks very similar. So the GraphQL client, or commonly like an Apollo client, but you can even just use a simple HTTP request, almost like a REST request, but with some extra syntax. It's going to make use of the same querying language, the GraphQL querying language, to make and request data as it does in the server to define what data is available. So you've got an example here on the left-hand side of a request being made. So this would be attached as part of a HTTP request. And you're saying, hey, this is a query. We're going to call the query something. You can give a name to your query. So we're saying, hey, get pause. We're saying which query we want to run. So just to go back really quickly, we've got this query type being defined on the server. And one of the queries that's defined is this pause. And you say, hey, we've got a limit and an offset. So we've talked about typing for the data types. The other great thing is it's typed and very specific for all the queries and the mutations as well. So instantly we get a list of all the options that we have available to us in terms of this request. And if I was to change this 3 to a string 3, so in quotations, it would throw an error and say, you're using a string where you need to have an int. And so straight away, the server can be more predictable, the client can be more predictable. So in this example here, we're recreating the requirements used on the REST query example. So just to go back a few slides, apologies. So this nasty slide here with 3 different requests being made, potentially lots of different times, just so that we can get a list of dogs, whether they're suitable with cats and where they are. That's the query we're trying to solve here. If you remember that took us 3 separate queries, each dependent on the previous, causing 3 round trips of request responses at least to get the data that we needed. So here's an example of how we've managed to reduce it to a single query. And not only that, but we've managed to ask for the exact information that we require, not any more and not any less. So what we're doing here is we're saying, hey, we want all the pause. The return type of the pause query, let me just go back again. You can see here is an array of type dog. Type dog has these fields, so we know which fields we can query on this. And one of those fields, and I'm going to talk about this in a bit more detail, is just shelter. And shelter isn't a string, it isn't an ID, it isn't a Boolean or an int. So it's type shelter, and type shelter is then defined down here. And so we know what fields can be defined on this as well. So here we've got basically the query being executed. And these fields are on type dog. So we're asking for the ID, we're asking for the name, the cover photo, whether it's reserved, and finally, whether it's suitable with cats. And because we need to know where it is, we're just saying, hey, for this dog, for the shelter that it currently resides in, give us the name and the location of it. So what have we actually solved here? So that's pretty obvious, really. We've solved most of the key problems we identified. So overfetching and underfetching is no longer an issue. We've got exactly the data we need, no more, no less, keeping the transmission of data as light as possible for these low powered clients. What are the types of the return data set? So we know that the API tells us the type. So we know that problem's been solved. What if there is no cover photo? Well, I'm going to go back a step just to show you why this is interesting. So cover photo, you can see here it says string. You might wonder why some of these have exclamation marks and some have not. So the exclamation mark in GraphQL syntax tells you that the field is non-nullable. So what this is saying is that the cover photo is a string and it cannot be null, i.e. it will always be a string. You get into some pretty weird things when you start looking at things like this, where you've got 2 exclamation marks. What the hell does this mean? What this means is that photos will always return an array because it's non-nullable. So you can't have null as a result for photos. So it'll always be an array, but it could be empty. But if it does contain something, the thing inside the array must be a string. It can't be null again. So it tells you very clearly what the data structure is. So with that, we know that if there is no cover photo, it can't happen. We don't have to worry about that. It's impossible. There will always be a string there. What if there are no photos? We just described, hey, one thing, we don't need to worry about photos because we never actually asked for photos in the first place. So we haven't even fetched them. So there's a great example of overfetching, now not overfetching. And we also know that the array will always exist because it's non-nullable, as I just told you. And we also know that the entries will be valid strings because they're non-nullable too. What if they're uncertain about Queen Elizabeth's suitability with kids or cats? Let's just, again, we'll go back. You'll notice that the suitability with kids and cats and dogs is a Boolean, but it does not have that exclamation mark on the end. What that means is that it could be true, it could be false, it could be null. There's a very clear understanding there given to the client that, hey, you actually have to deal with all three eventualities of that. So if it's not known, it's null. It's fine. Finally, the last problem we highlighted was APIs are often tied to views and UIs, causing loads of backend changes whenever a new UI sort of comes about. The API is only tied now to the data that it can possibly deliver. The client applications can decide exactly what they want and how it's structured, giving them complete freedom to iterate without API changes most of the time. So we've decoupled the back end from the front end, which means that front end development can just press ahead and get what they need to get done. Without having to have backend changes to support them. Hopefully, I'm going to pause there. Has anyone got any pressing questions? Is there anything in the doc that I need to be aware of before we go into the demo of GitLab? Nope.
I just see one question.
Do you want to verbalize it? Oh, it's more of a note.
A question, but more of an observation. You could go through the demo, and I could touch on it at the end.
Cool. Okay, so when it comes to GitLab, how does GraphQL use? There's a few notes in the deck. So take a look at this page in the deck, and there's a few further reading links as well. So the things to note really here are that the GitLab GraphQL API endpoint is located at API/GraphQL, not v3, v4, which obviously the REST endpoint. There's a fair amount of documentation. It's mostly developer focused, but do have a look at the documentation for GraphQL in our docs. And then finally, I'm going to show you something called GraphQL, which is a really interactive GraphQL explorer. So I've already got it preloaded here. And so if you go to gitlab.com//GraphQL Explorer, you'll be presented with this page. And this is a GraphQL Explorer, but it's actually just a full GraphQL client. You can do whatever you want with it. So get rid of that for a start. So you might be staring at this straight away going, where do I go from here? So first and foremost, docs are built in. And this is another great thing about GraphQL. It self-documents. One of the endpoints that a GraphQL server actually provides is the schema endpoint, and it will deliver this full schema to any client that asks for it. And so as a result here, you can see we've got two root types: queries and mutations. That's always the same in all GraphQL endpoints. Sometimes you might see subscriptions as well, which is actually a way of live updating data with GraphQL. But we're going to look at this query endpoint. So you can click on query, and all of a sudden, now you can see every single query you can make in GraphQL. Now, I know there's a few that I would like to use. So we're just going to write a query, and we're going to do live demo query. And we're going to ask for something. So first and foremost, if you don't know what to ask, you can just press Command Space, as you can in most IDs, and you're going to get a list of all the different things that you can do. I know that I want to look at projects. So we're going to look at projects. And if I mouse over projects now, it says it has to have a selection of subfields. And so I need to define what it is I want from projects, but also if I don't know what options are available to query, I can open a bracket and it's going to tell me everything that's available on this query. So for example, I'm going to use search. And if I don't know what search is, I can mouse over search. It tells me that it's a string. If I want to, I can even click on this and it'll take me straight to the documentation, so you can see exactly what's queryable and even more descriptions as to what's available there. So I'm going to do GitLab environment toolkit as a search term. And now we need to tell it what data we want back. Very, very common. So it's very common in GraphQL for each node, or what we call node in the GraphQL world to return an ID. It's almost explicitly expected that there is an ID. And there's a couple of extra bits of syntax when we're talking about our endpoint. So you quite often see this syntax being used. So edges, nodes, and page info. There is a link in the deck, which in fact the very first link in the further reading, which is talking about edges, nodes, and cursors. It's really mostly to do with pagination and cursor-based pagination and how you go about doing that. And it relates to edges are the lines between the nodes in the graph, etc. There's lots of information there. Do take a look at it. But effectively, if you just think of nodes as the result, this is now a project, so we can see name. And if I just run that query, so just by pressing Command Enter for me, or just pressing this button up here, you're going to get the result back. And so instantly you can see, hey, we've searched for a GitLab environment toolkit, and I can see some data's come back. I can see there's projects, and I can see there's nodes, and it's an array of projects. And if I mouse over nodes again here on the left hand side here, you should see it's nodes returns an array of type project. If I want to see what fields are available on the project, I can click on that and I can see all the different fields that are available, including queries themselves. So like name is fine. There's also a name with namespace. So if you want to know exactly where they are, it tells you where they are, which is quite cool. And when it comes to the REST endpoint, this is pretty much the level you can get to. You can say, hey, I'd like a project, or I'd like to search for projects. And the only thing you can query is things that exist on this project. But this is GraphQL, so let's go a bit crazy. So all of a sudden we can query issues. Issues aren't stored in the same place. And we can get an ID. We can get probably an assignee. Yeah, let's go for an assignee. Or even more crazy than that. So it'll also auto populate things if you miss something out. So assignees is actually, because it's an array, I actually forgot that assignee. Obviously, we can have more than one user assigned to an issue. It's an array, so it's auto-populated edges and it's auto-populated nodes and IDs. And what you'll probably find here, is username. So if I do that, so all of a sudden now we have nodes. So each of these nodes represents a project, and this project has no issues. Fine, but down here you can see the GitLab quality GET project has quite a few issues. So we've got some issues here with some IDs and nobody's assigned. And then see down here, we've got Grant being, not surprisingly, Grant's assigned to all of them. You know, there we are. But you can, what I'm saying is we've got suddenly now access to 3 different types within this graph, all from one query. So we've got projects, we've got issues, we've got a user as well. So if I want to drill down into more information on the issue, so who created it, when it was created, if I want to drill down more into Grant's user, which is probably a bit dodgy, but we'll start going down into this. I can add more and more data to this, and I can remove data at will. So hopefully that kind of gives you an idea as to the kind of power that you can have with this GraphQL query system. Do use the GraphQL Explorer, have a play. There's a lot here, and it is, like I said, self-documenting. The most important thing is basically start off with a query. You can start off with that, and that is all you need. And then you can pretty much from there just look and explore from what's available in the API. There is also authentication. You might have noticed at the moment that I'm requesting a public project, and there's a reason why. It's because I'm not logged in yet. Down here at the bottom, you've got query variables. You can attach headers and authentication mechanisms as part of the query variables. There are other ways of doing it. It's all documented in our docs. So yeah, that's pretty much it. Does anyone have any questions at this point? Or does anyone want to see a demo of anything particular in the GraphQL land?
So do you see a couple questions in the doc, and then we still have our customer observation?
Okay.
I'll go ahead and verbalize the customer observation. I think this is actually confirmed on the engineering side. So on the vulnerability management in GitLab, I think they went GraphQL first on the data. So say if you have a customer that's trying to pull information together, or they're trying to make their own vulnerability dashboard,
yep,
suggest the GraphQL endpoint, because right now the REST endpoint is missing a few properties, and I think they're trying to close a gap on that. But that was just something that came up and might be helpful.
Yeah, the downside to being GraphQL first, as I mean, in the grand scheme of it, we've been GraphQL first now for quite some time, but there is still plenty of REST endpoints that haven't been as yet updated. And so as a result, they haven't had that GraphQL love, and they're not necessarily available there yet. So it is a bit, there are some things that are still definitely missing from the GraphQL schema. I've seen a massive amount of work being done on it on the last probably 6 to 9 months. So it's constantly getting more and more stuff added to it. And you really have the flexibility to query whatever the hell you like, really, which is fantastic. So unlike the REST endpoints. So yeah. Questions? Let's have a look.
Looks like we have a couple questions from Chris Wang.
Yeah, thanks for the presentation, Simon. That was really awesome. So I think that the first two questions are basically related. The first one is basically, are people using the GraphQL endpoints that you've seen in practice? So customers, partners, is it something that people know about? Yeah, so that's the first question. And the second one is about versioning. So someone put a link about, philosophy behind versioning GraphQL endpoints. They basically said not to do it. Yeah, so I'm just curious. I guess sort of like a related question is, in our documentation, we talk about eventually creating potentially another version of our REST API, version 5, and how that have a better synergy with GraphQL. So when is that happening, if there's any plans to actually do that?
Lots of questions all in one. So yeah, so first and foremost, let me tackle the ones that I'm more familiar with. So versioning of GraphQL endpoints is generally not recommended, and it comes down to, if you follow best practices right from the word go, and you don't tie your data schema to how it's actually implemented in your database, then what that tends to mean is that your schema represents the data that people are interested in fetching, not how it's stored on the back end. And so what that means is that typically, even if you change databases structure in the back end, it generally doesn't mean that your data schema on the front end changes. What the other best practice is, start small. It's much easier to add things than it is to remove things from a GraphQL schema because of that very reason, because it's not versioned. There is actually a way in certain servers. So Apollo server has a flag to mark a field as deprecated. And so that will warn you every single time you make a query to that field that, hey, this feature is deprecated and it's going to be removed. So there are ways of deprecating fields. It's generally considered like the last resort though. So yeah. Are there any customers using GraphQL? Not directly, I think, but I think more and more I've definitely got some customers who are using our GraphQL endpoints with scripting tools, their internal tools. That's really the main use case for it at the moment. And to be honest, as I alluded to earlier, it was missing in some pretty key functionality until fairly recently. So only now I think is it at a point where I'd really say, yes, it does. Make sure it does what you need it to do, but it is very usable now. Yeah.
When do you think that GraphQL will become a first-class citizen? Or is that even like in the plans? So it's just sort of like, let's just do REST for the time being, stick with that. That's what everyone's doing. That's what the integrations are at. And, GraphQL is this thing on the side. We believe in it. Eventually we'll merge it in.
So the part of the reason we're GraphQL first means that any new feature being added to the product now must have a GraphQL endpoint first and foremost, and it may not get a REST endpoint. That inevitably will drive users over to using GraphQL over time if we continue down that route. That is more of an engineering decision than I'm aware of. There's an engineering, there's actually a GraphQL weekly or bi-weekly meeting for any GraphQL related queries that the engineering team holds. I was actually partaking in that for a while. So if you have any like engineering focused questions, I'd go there and ask them.
Cool.
Yeah, I've seen even in some cases, the REST APIs are being deprecated in favor of GraphQL. For example, if you want to pull the results from security scans, that I've been exploring that with a customer and was told definitely go the GraphQL route because it's more complete and they're not they're probably going to pull the APIs.
There's also some really interesting things. I don't want to get into too much detail as to the back end implementation, but how GraphQL is really resolving all of these links between things. It generally does like a multi-pass thing. So what you'll do is it'll run the resolvers for the query that you've got. So it'll run that query for the dog, and it would resolve all of those fields, making database requests. And then what it would do is it would pause and wait one millisecond and kind of do another loop, and then it would realize that it needs to go and get the shelter information. Then it would go and do that. And what it's doing is it's very efficiently going and getting all that data in one go. If you quite often, one of the biggest problems with REST is overfetching, and that actually causes extra headache for the server as well. You're asking for far more data than you actually need it to provide. So there is some pretty big efficiency savings as well with GraphQL on the back end as well as the front end.
Yeah, follow-on question for that. I think that that's really interesting what you're talking about from a performance perspective. I'm wondering, obviously we know about GitLab being slow and how that's like something that we're trying to work on. I'm wondering if anyone knows if our new user interface views actually leverage GraphQL versus REST for when they're fetching data. Like, are we doing this ourselves? Like, I'm curious if anyone knows that.
So the big implementation, one of the things I've put in the resources in the last slide is links to Apollo Client. We are making use of Apollo Client. Apollo Client was designed originally, or is still designed for React, not Vue, which we make use of to do our new front end UI pages. So, but we have got a wrapper for Apollo Client for Vue, which has been maintained, I think, partially internally by the team, but it's also an open source project. And what that means is that most of the pages that are being rewritten in Vue, a lot of them are making use of the GraphQL API.
That's awesome. Is that helping with performance?
Yes, it is. Yeah. Yeah.
Awesome.
A lot of the pages that have been rewritten in Vue are much more performant. Yeah. Yep.
Selfishly, I was hoping to jump us back to one of the earlier questions Chris had asked about customers using the GraphQL endpoint. Our scalability folks had pushed me to push one of our customers to adopt this because of that N+1, sort of fetching problem you get with REST. And the biggest pushback I got from this customer was, well, we're using a library that, that basically exposes in a very elegant way for our code, all the REST endpoints. And, their supposition was, well, until that library or a similarly good library that's actively maintained sort of offers that for GraphQL, we're not really incentivized to switch. But in asking that question, I think I'm realizing I'm actually not familiar with any sort of libraries structured that way for GraphQL for other tools. Certainly not for GitLab, but even for other tools, I'm just not sure.
Because you don't need it. And
right.
so because it's self-documenting and effectively most GraphQL clients, like I said, the very first thing they normally tend to do while you're developing is they actually make the request to the schema endpoint, which gives your IDE the schema that you're coding against. And so you've got that live while you're editing view of whether you're coding correctly for the types that are expected from the endpoint. And the requests, you can't, it's very common practice, like you say, to wrap REST endpoints in sort of CLI tools or those kind of things, because they're complex and you can make easy mistakes. The idea with GraphQL is because it's typed, error checked and self-documenting, you don't really need to do that. Yeah.
So what you're saying is I was bamboozled by this customer and they really just didn't want to do the work. Okay.
Yeah, I mean, so the biggest challenge I would say with GraphQL at the moment is if you don't use a client, you can just make GraphQL requests using HTTP requests, just to be completely clear. At that point, it is kind of a bit clunky because you're not getting any of that integration, and you also aren't managing cache and state. So part of this, one of the other great things about GraphQL is if you've got this data coming from the server and you've got IDs and you know what types they are, you can actually store that information on the client. And then if another query on another page requests the same data, it doesn't request it from the server, it actually requests it locally from the cache. And that's part of what Apollo Client does. Again, there's links on the last page in the resource slides to learn more about that. But there's a lot there. You get a lot of benefits, but Apollo Client is really the thing that makes this much easier. There are other clients for GraphQL available. Yeah.
Thanks, Simon. Great presentation, by the way.
Thanks.
Really great presentation. We have 5 minutes left. If there are any final questions, comments? All right. Thanks so much, Simon. That was really great. We really appreciate your time.
Thank you. Cheers all. Have a
Cheers.
great day.
Yeah. Thanks very much, Simon. That's awesome.
Cheers.